Okay guys, first section in chapter 6. We are going to talk in this chapter about three things really: law of sines, law of cosines, and then find the area of an oblique triangle. So it's not going to be your typical 1/2 base times height area formula. We have a couple other formulas we're going to talk about involving sine and then involving some distance stuff as well for an oblique triangle. So to solve today, really you're going to talk about law of sines, and in particular case 1. There are 4 different cases which we will get into. So the law of sines has to do with the triangle and solving for all unknown sides of a triangle. We can't use SOHCAHTOA, right triangle trig here, because this is not going to be a right triangle. But if we take the ratio of an angle to its side, you could create 3 ratios: sine of alpha over A, sine of beta over B, and gamma over C. They would always all be equal to each other. So that's going to help us find and sort out for missing sides and angles. Now, one thing to keep in mind, your 3 angles of a triangle always add up to 180, so we're going to need that a lot, and we cannot do Pythagorean theorem in this chapter because they are not going to be right triangles. You'll notice we're only going to be using 2 of these 3 ratios at any given one time. So for example, if we were using these 2, we would have 3 knowns and 1 unknown, and that's what we're solving for. Okay, sometimes it can be difficult to decide which ratios to use. You just need to remember you have to use the ratio where you're going to have 3 known things and 1 unknown thing, and then that way we can solve for that unknown variable. The law of cosines is similar, except for now we're using cosine instead of sine, so we're still going to be talking about triangles. Same kind of triangle there. We can use any illustration we want. And you'll notice that we have C, B, and A, 3 different formulas here. Really, they're all the same thing. It just depends on what sides are known and unknown. And you'll also notice that C, and this is called gamma, are opposite of each other. B and beta, and A and alpha. So the angle and its opposite side are going to be on different sides of the equal sign here. So this is alpha, beta, gamma. Sometimes you'll see it as capital A, capital B, or capital C here. Okay, so the different cases, the first one is when we have 2 angles and 1 side. It doesn't matter if the side is included or not. Case 2 is when we're going to have 2 sides, and it's very important here that the angle is non-included. This creates something called the ambiguous case, which we'll talk about a lot in the next video. Essentially, we're going to have 0, 1, or 2 triangle solutions. And we'll talk about how you can identify the difference between them. Case 3, then we switch over to law of cosines. That's again when we have 2 sides and now the angle is included. That's an important piece. So non-included is law of sines, included is law of cosines, and then the last one is if we were to have all 3 sides, and then we'd be trying to find the angle. Okay, so case 1 is what we're talking about today. Like we said, the location of the side is 0, 11. It doesn't matter if it's included or non-included. So here, side angle angle, you have a non-included side, or angle side angle, you have an included side. An example of what that would look like here, we have actually angle angle side. So this, or side angle angle, doesn't matter which way you say this one. In this case, it will be non-included, but again it's going to be law of sine. So if I write that down, I can say sine of alpha over A equals sine of beta over B equals sine of gamma over C. Now oftentimes there's more than one way that we can figure this out. But you'll notice that we have alpha and A. So in this case, we're going to have to use that first one, sine of 40 over 4, and that will equal, and now we're going to have, since we have beta, we need to use that one. So sine of 60 over B. So we plugged in 3 knowns, and we have 1 unknown. Several different ways we can solve this. Easiest way is probably just to think of cross multiplication. So we're going to have B times the sine of 40 equals 4 times the sine of 60, and then we could divide by the sine of 40, so we'd have 4 sine of 60 over sine of 40, and that tells us that B will be equal to 5.4. So we have 5.4 here. That should be a 5. And now if we want to find gamma and C, what we need to do is say, okay, all 3 angles of a triangle add up to 180. So if I take 180 minus 40 minus 60, I'm going to get 80 degrees for gamma. And now we can plug in, so sine of 40 over 4, I'm still going to use alpha and A because those are the original givens, equals, I'm going to say sine of 80 for gamma, and then our unknown is C. we go through the same cross multiplication process here. If we do that, C is going to end up equal sine of 4 times sine of 80 over the sine of 40. And then solving for C, we're going to get 6.12. So we have 6.12 on this side. One thing that's a quick, easy check to see if answers make sense is you always know that your smallest angle is opposite the smallest side, which happens here, 40 and 4. The largest angle, 80, should be opposite the largest side, 80 and 6.12, and 60 and 5.4 in the middle, so they should be equal in the middle as well. Another thing is that you need to make sure all of these are dealing with degrees. So if your calculator's in radians, make sure that you're changing that before you come to class, because pretty much everything we're going to deal with in this chapter is going to be in degrees. Another example of this one is when we have our included side. So now, same rules, but now we have angle, side angle. So we know C, we know beta, and we know alpha. If you think about law of sines, though, the problem here is that we don't have any one complete ratio. No matter which two ratios we use, we'd have two unknowns. So we actually need to start by finding our gamma in this case, which we're going to do by 180 minus 15 minus 35, and that is going to give us 130 degrees for gamma. Now we have a complete ratio in the sine of 130 over 5. And that could equal, it doesn't matter which one we start with, I'm just going to start with alpha, so sine of 35 over A. And plugging in and solving, same idea, cross multiply. If you want to change sine of 130 and sine of 35 into decimals, that's fine. But if we cross multiply and then solve for A, we're going to get 3.7 for this side. So 3.7. And we're going to do the same process now for beta. We're going to say sine of 130 over 5 equals, and then we need to do our gamma, so sine, I'm sorry, not our gamma, our beta, sine of 15, come on, over, let's see if we can get this close, there we go, over, let's see, B we said, right? So solving for B, doing your cross multiplication and simplifying, we'll end up with 1.7 for B. Again, our quick recap check, 15 smallest angle opposite the small side, largest side by far 5 opposite the largest angle by far, and 35 and 3.7 opposite of each other as well. So case 2 is going to be very similar. We're going to solve it the exact same way. We're just going to change things up because it'll be the ambiguous case. Again, remember that can be 0, 1, or 2 triangles. And really, the tough part with this is just doing your cross multiplication correctly, making sure you're in radians, and following basic order of operations to make sure we don't make any silly mistakes there. See you next time.